Calculation of del U and del H for 1 mole of ideal gases. First del U find out, after that similarly del H find out. So Cv equal to du divided by dt. du equal to Cv into dt. For find changes, del U equal to Cv into delta t. Delta U equal to Cv into T2 minus T1 for n mole of ideal gases. For n mole of ideal gases, del U equal to Cv, number of Cv into T2 minus T1. Similarly, del H equal to number of Cp into T2 minus T1. Measurement of del U and del H using calorimeter. Calorimeter used amount of heat change. Calorimeter used only amount of heat change. In our chemical or physical change, calorimeter the temperature change process measured by directly proportional to heat capacity. C is equal to Q divided by mass into delta T. We calculate the amount of change only two different conditions. One, constant volumes. Second, constant pressure. Qv equal to constant volume, Qp equal to constant pressure. First, del U measurement. Chemical reaction heat evaluated constant volume measured by bomb calorimeters. The inner viscera of the bomb is covered by strong steel. That means strong steel. That is steel form. That area is the steel bomb. The cover fit tightly viscera means by metal laid with screws. That is the bomb calorimeter. The weighed amount of substance taken in the platinum cup. This is the weighed amount in the platinum cup, yellow color. That the electrical wire strictly instant the kindly combustions. That is electric wire will be combustion in the screws. The tightly closed pressure with excess of oxygens. The excess of oxygens will be given oxygen supply. Oxygen supply will be given. The bomb impressed water in the inner volume of calorimeters. The blue color is the water. The known amount of combustion substance burned in oxygen forms. The known amount of the substance heat evaporated during the reaction observed by the calorimeters. How much heat is evaporated, as well as water which bomb is impressed. The change in temperature measured Bergman calorimeters. That meter is called Bergman thermometers. The bomb sealed volume does not change in heat measurement. That is, does not change in heat measurements. That combustion constant volume used del U C. Heat observed by calorimeters. That means Q1 equal to K into delta T. That K is called calorimeter constant. MC equal to MC and C. MC is called mass of the calorimeter. Cc is called heat of the capacity. Q2 is equal to mw into Cw delta T. mw means mass of molar mass of water. Cw means heat capacity of water. How much means 4.184 kilojoule Kelvin inverse mole inverse. Therefore, del U C equal to Q1 plus Q2. So Q1 supply K into del T plus MW into CW del T. Del T with common, so K plus MW into CW del T with common. Calorimeter constant can be determined burning non-mass standard sample. The sample used which one means benzoic acid. Sample used benzoic acid. Benzoic acid of heat combustion minus 3227 kilojoule mole inverse. So delta H C pressure equal to delta H C pressure volume plus del Ng RT will be measured. Application of bomb calorimeter. Bomb calorimeter used for amount of heat released combustion reaction. It is used to determine calorific value of food. Bomb calorimeter used in many industries such as metabolic studies, food processing, exposing, testing. Next B. Del H measurement. Heat change constant pressure at atmosphere can be used coffee cup of calorimeters. Coffee cup of calorimeter. The systematic representation of coffee cup of calorimeter will be given the labels. It acts as a good adiabatic valve and does not allow the transfer of heat produced during the reactions for surroundings. The entire heat energy absorbed water inside the cup. This is for coffee cup calorimeters. Inside the bomb calorimeter will be thermometer, Bregman thermometer applied. The stirrer will be present, reaction mixer, and nested instead of cup instead of copper. Don't allow the heat energies. Equation Q is equal to mW Cw del T. mW means molar mass of water. Cw means molar mass of heat capacity. 4184 kilojoule Kelvin inverse mole inverse. Next, application of heat combustions. First one, calculation of heat formations. Heat of formations. Heat combustion organic compounds can be determined considerable or employ calculate the formation. For example, standard enthalpy heat formation of methane. See the reaction. Carbon plus hydrogens. How many hydrogens? 4 hydrogens used methane produced. That carbon is the as like a graphite. Hydrogen is the gas. Methane is also a gas. In this reaction, heat of formation delta H of degree equal to x kilojoule mole inverse. That is the calculation of heat formations. That value minus 74.7 kilojoule mole inverse. Calculation of calorific value of food and fuels. The calorific value amount of heat produced calories are joules. 1 gram of substance completely burned. The SI unit of calorific value joule kilogram inverse, usually expressed in calorie gram inverse. Next, heat of solutions. Heat of solution is defined by change in enthalpy. When 1 mole of substance dissolved in specific quantity of solvent given temperature. Next, heat of neutralization. Heat of neutralization. Heat of neutralization, change in enthalpy gram equivalent. Gram equivalent on acid neutralize 1 gram of equivalent base and vice versa. A dilute solution. For example, acid HCl, base NaOH, reacting means salt to produce NaCl plus water. So water acts as a neutralizer. So delta H value minus 57.32 kilojoule. As like acid means simply H plus, base means OH minus, gives H2O. The delta H value will be same because neutralization 57.32 kilojoules. That acid will be same, HCl plus KOH equal to, base will be different. So remove salt plus water. Delta H value will be same. That one acid, one base neutralize means salt will be produced and water. So the neutralization value delta H equal to minus 57.32. Next topic, molar heat of fusions. Molar heat of fusion. The change in enthalpy, 1 mole of solid substance converted into liquid state. Solid substance converted to liquid state, that is called molar heat of fusions. For example, H2O taken solids 273 Kelvin, that liquid will be coming. The delta H fusion equal to plus 5.98 kilojoule. Next, molar heat of vaporations. Molar heat of vaporations. The change in enthalpy, 1 mole of liquid. 1 mole of liquid change to vapor. Example of molar heat vaporization, H2O liquid state converted to 373 kelvins, water come to vapor state. So delta H vapor equal to plus 40.626 kilojoule. Next, molar heat of sublimations. Heat of enthalpy change in solid directly to the vapor state. That is the heat of sublimations without changing into the liquid state. So example of molar heat substitution, iodine solids converted to 373 Kelvin, iodine vapor state. Delta H substitutions sublimation equal to plus 62.42 kilojoule. Next, heat of transitions. The change in enthalpy, 1 mole of element change to from allotropic form to another. Allotropic form to another. Example, carbon to carbon. Allotropic means reactant side carbon diamond state. In product state diamond carbon graphite state. That is the allotropic changes. So delta H in this reaction, delta H transitions equal to plus 13.18 kilojoule. 13.18 kilojoule. Similarly, sulfur. Sulfur is the monoclinic to sulfur rhombic sulfurs. Monoclinic sulfur to rhombic sulfur. Delta H transition equal to minus 0.067 kilojoule. Next, phosphorus. White phosphorus to red phosphorus. So here in this reaction, delta H transition equal to minus 4.301 kilojoules. So heat of transition, first graphite, first carbon, second sulfur, third phosphorus. Next, Hess law. We have already learned that heat change chemical reactions equal to different internal energy del U, and heat content del H will be measured. That since del U and del H functions of the state of the system, heat absorbed or heat evolved. In generalization of known as Hess law. For example, the pressure and same weather takes place singular multiple steps. Singular multiple steps involved. That means initial to final state will be single step also present and multiple step also present. All are addition is used in Hess law. For example, A to B, that means delta H reactions. That A is given X, that is called delta H1. X to Y, X to Y is called delta H2. Y to B, delta H3. That is the single step. First is the single step, here multiple step. Now delta H reaction equal to delta H1 addition, delta H2 addition, delta H3 additions. That is the single to final steps. That means initial to final steps. Next, application of Guess law. Guess law can be applied to calculate enthalpy reaction difficult to measure. For example, very difficult to measure heat of combustion graphite to give pure carbon monoxide. Now, carbon to carbon dioxide, that used delta H1, used O2. That is the delta H1, that is the single step. Carbon is given carbon monoxide. Carbon monoxide, that means of O2 is step delta H2. Carbon monoxide will be given carbon dioxide, again of O2 used delta H3. So according to Guess law, delta H1 equal to delta H2 plus delta H3. Delta H1 values minus 395. According to Guess law, delta H1 equal to delta H2 plus delta H3. Delta H1 value minus 393.5 kilojoule. Delta H2 you don't know X. Delta H3 minus 283.5 kilojoule. So X equal to minus 110.5 kilojoule. Next, lactic energy, symbol del H lactics. Lactic energy defined amount of energy required completely removed. For example, NaCl gives Na plus Cl minus. that solid converted completely removed the constituent ions formed crystal lattice to infinity distance. The delta H lattice equal to plus 788 kilojoule mole inverse. That means the amount of energy required to amount of energy required to NaCl completely considered ions, that is called lactic energy. That lactic energy converted means plus 788 kilojoule mole inverse. Next Bonhoeffer cycles. Bonhoeffer cycles. Next, Bonhoeffer cycles. Bonhoeffer cycles approach analysis of reaction energies. Analysis of reaction energies. Two German scientists will be explained. First one, Max Born. Second scientist, Fritz Cooper. The both name is mixed. So Bonhoeffer cycles. Bonhoeffer cycles and examples: metal solid state plus of X2 gives metal X solids. That is the delta H fusion. Metal converted to metal gas. That stage is called delta H1. X2 is in X gas state. Delta H2. Metal gas again converted to metal ions. Delta H3. X converted to X ions. Delta H4. So both are combined to metal X, that is the energy. So now the calculation: energy is equal to delta H1 addition, delta H2 addition, delta H3 addition, delta H4 additions.